Hello everyone. Today we are going to discuss the second type of induction motor, capacitor split phase induction motor or capacitor start induction motor. In the last lecture we have discussed the single phase induction motor, resistance start induction motor, resistance split phase induction motor. So continuing with this topic, we can see here that capacitor split phase induction motor, it is identical to resistor split phase motor, except that the starting winding has as many turns as the main winding. In this, the number of turns of starting winding and main winding are same, but a capacitor is connected capacitor C is connected in series with the starting winding. It can be shown in the next figure. I will show you. The value of capacitor is chosen such that IS, starting winding current, leads to the main winding current by about 80 degree, nearly about 80 degree. So our main aim is that we should give a phase difference between the current of starting winding and main winding. So this phase difference is provided by the capacitor. It is considerably greater than 25 degree, which is found in the resistor split phase motor. Therefore, the starting torque will also become high, and it is much more than that of split phase motor. Again, the same procedure is applied when the starting winding is opened at the time when the speed is 75% of the synchronous speed. At that time, the centrifugal switch comes into existence and it switch open the starting winding, and only the main winding will remain in the circuit. The motor operates as a single phase induction motor and continues to accelerate till it reaches the normal speed. Characteristic: the starting characteristic of the capacitor start motor are better than that of resistor split phase motor. A reason behind this is because the phase difference is nearly about 85 degree. That's why the starting torque is also high. Both the machine possesses the same running characteristic because the main winding is identical. The phase angle between the two currents is 80 degree, so it is higher than 25 degree as compared to the resistor split phase motor. Consequently, the same starting torque, the current in the starting winding is only about half of that in the resistor split phase motor. Therefore, starting winding a capacitor start motor heats up less quickly, and it is well suited to the applications involving frequent starting periods. It is used where frequently starting is required. You can see in this figure the difference between the starting current and the main winding current is nearly about 80 degree. This is provided by the capacitor connected in the starting winding. So this is all about the operation of the capacitor start induction motor. Characteristic is shown same, nearly about as similar to the resistor split phase induction motor, but the starting torque is high as compared to that of resistor start split phase induction motor. So this is used where the power rating lies between 120 watt to 740 watt, and it is used mainly in refrigerators, air conditioners, compressors, reciprocating pumps and other loads which require high starting torque. So the only main difference is of phase angle between the resistor split phase induction motor and capacitor start induction motor, and due to this the starting torque is also high as compared to split phase induction motor. So this is all about capacitor start induction motor. We will discuss the next type in the next lecture. Thank you very much.